Hi all, wish you all a happy learning. This is M. Nirmala working as Assistant Professor in the Department of Computer Applications, Hindustan College of Engineering and Technology. Happy to see you again. This is a problem of implementation of regression algorithm. Before to start with the concept of regression implementation, let me give you a small introduction about what is regression. Regression refers to continuous values. It is generally a statistical method which is going to find the relationship between a dependent variable and two or more independent variables. It is generally used in predictive analysis. In general, regression is used to find the relationship between the input variable and the output variable. And to be very precise, regression algorithms target variables are always numeric in nature. We are going to find out the numerical quantity of the target variable. Let's take an example of predicting son's height from father's height. We are going to use a linear regression algorithm here where the data set comprises of only two values, father's height and son's height, and we have to predict the son's height based upon the father's height. So here the input variable is father's height and the output variable is son's height. I hope everybody is clear. Now to start with, we have to import all the necessary libraries. So we are going to import the necessary libraries, and my present data file is available in the location /machine learning/ml 2023 ml/lab, and I'm going to execute this particular cell to currently have my work directory as this. And now appropriately on executing this particular cell, I have moved to my current working directory as /machine learning/ml/2023 ml/lab. And now it's time for us to read the data file. The data file is called as father_son.csv, which comprises of only two columns. One is father column and other one is son column, and both the columns are in the form of numerical quantity. And now we are going to read the CSV file into a data frame, and the name of my data frame is df here. Now on executing this particular command, my data file informations are shown in the screen. Father and son's informations are shown in the screen, and to have a clear idea about how many rows and how many columns are available, this data set comprises of 1078 rows and 2 columns. So now executing df.shape, it gives me a clear picture that it contains 1078 rows and 2 columns. And to know about the column names and its respective data type, I'm going to execute my dtype command. df.dtypes will give you the data type. So father is a numerical quantity of float64 data type, and son is also a numerical quantity of float64 data type. And to check the data type of the variable, I use the command df.info, which displays that father comprises of 1078 non-null float64 values and son comprises of 1078 non-null float64 values. And to identify whether the particular data set comprises of any null values, so in order to check whether it contains any null values, I am going to use the command isNull.sum. On executing this particular command, the output shows that the father column as well as the son column does not contain any null values. The next command is describe. This method will help us to display the statistical information on the numerical values of the data set, like mean, standard deviation, percentile, minimum value, maximum value, total count of the columns. All these informations will be displayed. This is to have an additional information about the data set. And df.head command will help you to display the first 5 rows of the data set, and df.tail command will help you to display the last 5 rows of the data set. And if you want 10 informations or 10 last 10 rows to be displayed, then you can give 10 on the tail command so that it displays the last 10 rows of the data set. And now we are going for the model building, where in this particular data set, we are dividing the data into 80% training set and 20% testing set. So for that, I'm going to import my train underscore test underscore split package. So from sklearn.model underscore selection, we are going to import train underscore test underscore split. Right. Then we have to divide your given data set into x and y representation, where x refers to the input variables and y represents the target variable. So according to this problem, x is my father's height and y is my son's height. So now x is equal to df dot drop son. So which means x comprises of father's height and y comprises of son's height. On executing, x gives me the informations of father and y give me the informations of son. Now we are going to have the given data set splitted into 80%, 20% training and testing data set. Now the output of X train is father's 862 rows and the output of X test is father's 216 rows. Y train gives me the information of son and Y test give me the information of son. Now my given data set is perfectly divided into 80% of training data set and 20% of testing data set. Now I'm going to import my linear regression algorithm. Now I'm going to create a model called as my model is equal to linear regression open bracket close bracket, and for training the data, my training data is in X train comma Y train. For training the data, I'm going to use the command fit. So my model dot fit of X train comma Y train is helping you to train your data. And in order to know what is the score of my training data, I use the command score. Score is the function for displaying the training score. On executing this particular command, my training score of linear regression model is 25.08, which is very less. Anyway, let us test the model. What is my output prediction? So on testing, and I'm going to draw an graph for plotting the line, and for testing score, for displaying the testing score, I'm going to use R2 underscore score. R2 underscore score is the function for displaying the testing score of regression algorithm, and this gives me an output of 24.42. So my training score is 25.08 and my testing score is 24.42, which shows that this is a problem of underfitting, because once you have executed this problem, the output has to be appropriately nearly to 80 to 85% of training score and 80% of the testing score. Then we can come to a conclusion that the problem is working fine. But now the problem has a very minimal score, and I have tried with another algorithm of KNN. Let us see what is the output of my KNN algorithm. And the KNN algorithm also equally shows you the same output as 24.68 and 23.71 as my testing score. So this is a problem of underfitting. What is basically underfitting? Underfitting refers to a situation where a predictive model fails to capture the underlying patterns and relationships in the training data, resulting in poor performance on both training as well as testing data, which means in the training phase itself it is not able to understand the underlying assumptions of the training data set. If the training itself is a failure, obviously we will be getting an testing output also to be in a failure status. So this is a problem of underfitting data set. So the reason can be like insufficient model complexity. You may not have insufficient or you may not have sufficient training data, because here it comprises of only the 1078 rows. Under the 1078 rows, it is not able to understand the pattern. So probably it might be also one reason, feature not informative enough. We have only two features available here. So there is the features, probably the lag of features also might be one reason, incorrect choice of hyperparameters and data pre-processing issues. Suppose in this case the data pre-processing issues is not available, but still that is also one reason for my underfitting model. And outliers or noise in the data, if you have any outliers or noise in the data also, the problem may give to an example of underfitting output. So incorrect choice of algorithm. So let us have a close examination of the same problem, by which how the concept of underfitting representation is avoided. I hope you're clear with the concept. Thank you very much. Wish you all a happy learning.